Hi, my name is Brian Freestead. I'm the leader of the senior design team working on CySat-I. CySat-I is a CubeSat, which is a standard satellite protocol that was developed by Stanford. Our satellite is a 3U CubeSat, meaning 3 units of 10 by 10 by 10 centimeters stacked vertically on top of each other. It basically looks like a loaf of bread stood up straight. Our satellite is comprised of commercial off-the-shelf parts with just a handful of custom components. The project is run and funded by M2I, with CySat's overall project manager currently being Kenzie Kilcoyne, but it will be someone different in the future. The purpose of CySat-I has a couple of components to it, in my opinion. So there is the scientific payload, which is based off of a thesis by one of the project's advisors, Matthew Nelson. Basically, there is a special antenna on the satellite which is reading soil moisture content, and then we are doing some transformations on that with a software-defined radio and sending that data back down to Earth. However, this is largely over the heads of many of the people actually working on CySat, so CySat-I does have other purposes. It is a very good project and learning experience for lots of students, and additionally, CySat-I is paving the way for additional satellite projects and launches by Iowa State students. So, senior design's job in CySat is that we are the software team. CySat has a couple of other teams, such as a hardware team, a structures team, and each of those teams has its own leader. And all of those leaders of those teams is led by the project manager. As I said, currently that's Kenzie, but it will be someone different in the future. So senior design fits into the software aspect. We're basically writing all of the code that's going to be running on the satellite, and also we're making ground station software. There are a couple of hardware components that senior design is working on. For example, we have made two custom printed circuit boards. One of them is a voltage boost board, and the other one is a carrier board to basically interface the software-defined radio with the rest of the satellite. So there are a number of subsystems going on in the satellite that senior design has had to write software for. So as I already said, there's a ground station that we're writing in Python, and that's entirely custom code, utilizing some libraries. There's an onboard computer, which is on the satellite, and we're again writing all the code for that, although there are some middlewares potentially that we could use. There is an electrical power system. There is an ADCS, which stands for Attitude Determination and Control System. There is a UHF transceiver and antenna, UHF standing for Ultra High Frequency. There is an LNA board. There is a software-defined radio running on a field-programmable gate array. This is the payload of the satellite. And as I said earlier, there is a voltage boost board, which is sort of grouped into the analog components that we work on. So the onboard computer, abbreviated by OBC, and the EPS, standing for Electrical Power System, are both made by Endurasat, and they have provided us with some software, an SDK they call it. We've mostly stayed away from that though, as partially a learning exercise and also having to do with some of our issues with their code base. So pretty much everything that's running on the OBC is custom. The ADCS, like I said, is the Attitude Determination and Control System. Its purpose is to determine how the satellite is oriented in comparison to Earth, and is also able to rotate it using a magnet torquer. The UHF transceiver and antenna are the methods by which we can communicate with the ground station. The LNA board essentially modifies the analog data coming in from the radiometer that's capturing that soil moisture content. and then it's fed into the software-defined radio, which performs some additional calculations on it. Again, the script that does these calculations was written by Matthew Nelson, and then that is stored, and when the satellite is overhead of the ground station, that data is transferred back down, and the ground station saves it in a database. It also provides a graphical interface to communicate with the satellite and collect health data, etc. So as the leader of the senior design team, I do have some recommendations for what the team should look like in the future. I think that there needs to be an OBC lead. Preferably this onboard computer lead would also be the team leader. There should be someone who is the radio lead. They essentially take care of everything having to do with the UHF transceiver, the UHF antenna, making sure that the OBC and the ground station basically have black box interfaces with everything having to do with radio wave communications. There should be an ADCS lead whose job it is to write all of the control flow associated with the attitude determination control system. There should be a payload lead who works on the FPGA, which is currently running Linux, but would be best if it was a hardware optimized solution. And then the other two positions, I'm assuming that there are 6 positions if it's another senior design team. If not, these are just recommendations and general guidelines that can be tailored to fit your personal team. So I think that it would be useful to have a ground station lead who takes care of entirely the front end and some of the back end. Now, the back end ground station is going to be largely tied to the radio lead's job. So it's optional if you want to split up having the ground station be a front end and a back end lead, like having a different person manage both the front end and the back end of the ground station. The other option that I have asterisked here is a power lead. They would take care of the electrical power system, the EPS, and any of the analog components such as the boost board or the carrier board. Now, most of the boost board and carrier board work should be done, and the EPS doesn't have a lot of work left to do on it, so the EPS could be grouped in with the OBC, which is what I did during my time on the project, and the analog components could just be picked up by someone as a sort of like a side task. I also largely recommend that there is someone who manages issues on GitLab. That's one of the things that I wish that we had done better from the start, and also someone who has a sort of a subtask of leading testing on the project. It'd also be useful to have one of the members of your senior design team designated to take care of all of the computer engineering or electrical engineering or whatever your major is, all of the 491 and 492 tasks. They wouldn't do all of them, but they would be the person who makes sure that the other team members are informed about what those tasks are and what they need to do. Because the CySat project is very time consuming, and it's easy to lose track of the things you need to do for the senior design class, which are arguably not as important as the actual CySat project. Last thing is that I'd like to provide some contact information of mine so that if you have any questions or concerns, you can reach out to me. This contact information is going to be available not directly in this video, or at least my personal stuff. I'll put my Iowa State email, which will only be good for a little while. But my personal contact information, like my phone number and my personal email, will be available in some documents on the CySat GitLab, so that way only people who are on the project are able to access it. Alright, I think that is it. Good luck, and I hope that the satellite is launched.